immersing ourselves in the vastness of the universe. Humanity has always looked up at the stars with a mixture of wonder, curiosity, and a lingering question: are we truly alone? For generations we have contemplated the cosmos, gazing at distant galaxies and pondering the possibility of life beyond our little blue planet. That possibility, once limited to the realms of science fiction and philosophical musings, is beginning to take a more tangible shape in a momentous announcement. NASA's director revealed that the James Webb Space Telescope JWST has captured something extraordinary near the edge of our cosmic neighborhood. This groundbreaking development centers around Proxima B, the closest potentially habitable exoplanet to Earth orbiting the red dwarf star Proxima Centauri. Proxima B has long intrigued astronomers and astrobiologists alike. Located just 4.24 light-years away, it is not only relatively close in cosmic terms but also lies within its star's habitable zone, an area sometimes called the Goldilocks zone, where conditions might be just right for liquid water to exist. This is critical, as water is widely regarded as an essential ingredient for life as we know it. But the new revelation from the JWST goes far beyond this baseline curiosity. According to NASA's latest report, the telescope has detected a remarkable increase in the brightness of artificial lights coming from the exoplanet surface, an anomaly that could suggest the existence of a SETI or some form of organized infrastructure created by intelligent beings. Although these observations remain under intense scrutiny and require further validation, they are compelling. The brightness pattern does not match typical natural phenomena such as volcanic eruptions or auroras. Instead, it closely resembles the type of artificial illumination seen from orbit around Earth, lights that glow consistently during the exoplanet's night, which may indicate energy usage and even a civilization of some kind. Adding to the intrigue, scientists have also managed to begin analyzing the chemical composition of Proxima B's atmosphere using the Webb telescope's advanced spectroscopic tools. These findings could offer a treasure trove of information about the planet's environment, its potential to support life, and perhaps even clues about any biological or technological processes occurring on its surface. The importance of this discovery cannot be overstated. The James Webb Space Telescope, launched to explore the earliest moments of the universe and to study the atmospheres of exoplanets, may have just crossed one of the most important thresholds in modern science: the detection of life, or at the very least the detection of conditions strongly suggestive of it. With Proxima B now under the scientific microscope, the possibility that we may not be alone has taken a giant leap from imagination to data-driven theory. Proxima B became a household name in the astronomical community shortly after its discovery in 2016. The planet was detected using the high-accuracy radial velocity planet searcher HARPS, an incredibly precise spectrograph installed at the Loyola Observatory in Chile. HARPS operates using the radial velocity method, also known as the Doppler spectroscopic technique. This method detects exoplanets by measuring the subtle periodic wobbles in a star's movement caused by the gravitational pull of an orbiting planet. These minute shifts in the star's light spectrum are often the first signs of a planet's presence. In the case of Proxima B, the data revealed a rocky world, roughly 1.3 times the mass of Earth, orbiting its star every 11.2 Earth days. This relatively short orbital period means that Proxima B is much closer to its host star than Earth is to the Sun. Fortunately, because Proxima Centauri is a red dwarf, a star significantly smaller and cooler than our Sun, the reduced distance still places the planet within the habitable zone that said this is only the beginning of the story. The classification of a planet as habitable is far more complex than its size and distance from a star. Multiple factors come into play, including atmospheric composition, surface conditions, geological activity, magnetic field strength, and more. One of the most critical unknowns about Proxima B is its atmosphere, or whether it even has one. An atmosphere acts as a protective shield, regulating temperature and protecting the surface from harmful stellar radiation. It also plays a vital role in maintaining liquid water and supporting biological processes. Scientists are currently developing methods to study Proxima B's atmosphere, and the James Webb Space Telescope is proving to be an indispensable tool in this endeavor. By observing the way starlight filters through the planet's atmosphere during transits, astronomers can identify specific absorption lines in the light spectrum. These spectral fingerprints can reveal the presence of gases like oxygen, methane, carbon dioxide, and even complex organic molecules, each of which could be a potential biosignature. Another key factor in determining habitability is the presence and distribution of water. While Proxima B resides in a theoretically temperate zone, this doesn't automatically mean that it harbors oceans, lakes, or rivers. Scientists are actively looking for indirect signs of water, whether in liquid vapor or solid ice form. The existence of water in any of these states would be a promising indicator, but the search remains ongoing and challenging due to the planet's distance and the limits of current observational technology. Adding to the complexity is the likely tidal locking of Proxima B. If the planet is indeed tidally locked, it means that one side is in perpetual daylight while the other remains in eternal darkness. This stark contrast between the two hemispheres could create extreme temperature gradients and atmospheric dynamics that significantly impact habitability. The day side might be scorching hot while the night side could be frigidly cold, yet some models suggest that if an atmosphere exists, it could help redistribute heat and moderate these extremes, potentially allowing a habitable twilight zone along the terminator, the region where day transitions into night. Geological and atmospheric stability are also important considerations. Planets subject to frequent volcanic eruptions, strong seismic activity, or high levels of radiation from their host star might struggle to maintain habitable conditions. However, a certain level of geological activity, like plate tectonics, could actually be beneficial, promoting carbon cycling and helping to stabilize the climate over geological timescales. In the case of Proxima B, little is known yet about its internal structure, magnetic field, or geological processes, but efforts to infer these properties are underway. Another fascinating aspect of Proxima B's potential habitability involves the energy it receives from Proxima Centauri. Red dwarfs are known for their stellar flares, violent outbursts that can shower nearby planets with high energy radiation. If Proxima B lacks a strong magnetic field and a thick atmosphere, such radiation could strip away its atmosphere over time, drastically reducing its habitability. Yet despite this potential threat, recent JWST findings indicate the presence of certain atmospheric compounds that may suggest ongoing protection and regulation, possibly even biological processing. As researchers delve deeper, they are also searching for organic molecules, basic building blocks of life, like amino acids. The identification of such compounds could hint at prebiotic chemistry or even active biological processes. These investigations, while in their early stages, are being propelled forward by the capabilities of the JWST and other upcoming observatories that will continue to refine our Understanding of Proxima B. The detection of Proxima B was itself a remarkable feat, and the story of how it was discovered is worth revisiting. HARPS, the instrument responsible for its discovery, was engineered with extraordinary sensitivity. It uses an optical fiber to channel starlight into a spectrograph, where the light is dispersed into its constituent wavelengths. By analyzing these light spectra, astronomers can detect the minuscule shifts caused by orbiting planets tugging on their stars. These radial velocity changes, sometimes just a few meters/s, are detectable thanks to HARPS temperature-controlled environment and precision calibration. Following Proxima B's initial detection, its status as the closest potentially habitable exoplanet to Earth has made it a prime target for further study. The James Webb Space Telescope has expanded this mission to unprecedented levels of detail with its infrared capabilities. JWST can peer into atmospheric layers, detect molecular compositions, and even observe surface reflections and heat signatures, and now with a startling report of increasing artificial light levels on Proxima B, we find ourselves at a moment in history where science fiction edges ever closer to science fact. Despite these exciting developments, caution remains paramount. The data collected still requires rigorous peer review and confirmation through multiple methods. False positives are a known challenge in exoplanet research, and what might initially appear to be a sign of life could turn out to be the result of non-biological processes that said never before have we come this close to detecting potential signs of intelligent life outside our solar system. This newfound excitement surrounding Proxima B rekindles the age-old dream, the possibility of another Earth, a second home for humanity. Could we someday reach Proxima B? Theoretically, with advancements in propulsion and space travel, interstellar missions might become possible in the distant future. Initiatives like Breakthrough Starshot aim to send tiny probes at a fraction of the speed of light to nearby stars, including Proxima Centauri. If such missions succeed, we may gather close-up data within a human lifetime. For now, we are left with the tantalizing clues and the hope that more answers are just around the corner. The James Webb Space Telescope, alongside future instruments, will continue to push the boundaries of what we know as we refine our understanding of Proxima B and search for others like it. We edge closer to answering one of humanity's most profound questions: are we alone? So what do you think about Proxima B? With all this new information and the technology at our fingertips, is it possible that this distant world is not only habitable, but inhabited? And if so, are we ready for what that might mean for our place in the universe? The implications of discovering intelligent life, or even microbial life, on Proxima B would be nothing short of revolutionary. It would not only reshape our understanding of biology, astronomy, and evolution, but also challenge deeply held philosophical, theological, and existential beliefs. What would it mean for humanity to no longer be the only known sentient species? How would our societies react? Would it unite us with a sense of cosmic kinship, or further divide us as we grapple with a new reality? There's also a technological dimension to consider. If the anomalous light patterns on Proxima B are indeed artificial, created by an advanced civilization, it opens up possibilities that are difficult to fully grasp. Are these beings using energy in ways we cannot yet comprehend? Have they developed technologies beyond our current scientific models? Could they be attempting to communicate, or have they already tried? Such questions are central to the field of the search for extraterrestrial intelligence. SETI, which for decades has monitored the skies for radio signals and other signs of intelligent life, until now most efforts have yielded silence, but the findings around Proxima B reignite hope that we may finally have something to work with, something that could, with time and clarity, evolve into meaningful contact, even without definitive proof of life. Proxima B serves as a blueprint for future exploration. Its proximity to Earth makes it an ideal candidate for testing long-range observational technology, studying exoplanet atmospheres, and preparing for interstellar missions. The more we learn about its environment, its air, weather, terrain, and climate, the better we can design future missions and maybe even robotic landers. That said, there are still many technical challenges to overcome. While the James Webb Space Telescope has provided astonishing clarity and reach, it is still limited in what it can resolve directly. Proxima B, like most exoplanets, is too distant and too small to be imaged in detail. Most of what we know comes from indirect measurements,